In this video we are going to start chapter 10 circle of class 10. At first we will define what is a circle. You take 2 points, say one point O fixed point and another point P moving point on a plane, and this distance OP. If the point P moving on a plane in such a way that this distance always remain same, the point P is moving on a plane in such a way that the distance OP remain same, then this path also called locus, this path of the point P, the path of the moving point P is called circle, and fixed point O is called center of the circle, and the fixed distance OP is called radius of the circle. So a circle is the path of a moving point P on a plane which moves on a plane in such a way that its distance from fixed point always remain same. Fixed point is the center and fixed distance, constant distance, is the radius of the circle. Now the first theorem is the tangent. Tangent means any line touching a circle. This is a circle with center at O. If we draw a line touching the circle at one point, then this line is called a tangent. And the first theorem is the tangent at any point of a circle is perpendicular to the radius. So I am drawing a circle with center at O. This is the radius, and this point is called point of contact. At point of contact we are drawing a tangent, say PT, and the theorem is to prove that OP is perpendicular to the radius. So this proof is done through explanation. Mathematically, with proper theory, there is the proof cannot be done. It is done through explanation. Is like this. Consider a point Q. PT is the tangent. O is the center of the circle. You will first give the explanation. O is the center of the circle. PT is tangent. And what you are asked to prove? To prove OP perpendicular to PT, radius perpendicular to the tangent. Consider a point Q on the tangent other than P. Consider a point Q on the tangent other than P, not at P, distinct from P. Then if we join OQ, then obviously OQ is going to be greater than OP because point Q goes outside the circle. You can mention here, then Q point goes outside the circle. So we are taking a circle with center at O, at the point P drawing a tangent, and we are asked to prove the theorem. According to theorem, we have to prove OP is perpendicular to the tangent. Now taking a point Q other than P on the tangent, then join OQ, and then point Q is going outside the circle, and obviously OQ distance is becoming bigger than OP. That means OP is the shortest distance from the center to the line. That is, you can say OP is the shortest distance from the point O to tangent PT. Therefore, OP is perpendicular to PT. So this proof is done through explanation like this. Shortest distance from a point. The concept is like this. If we take a line and one point P, and if we draw a line from P to the line, join, and then if this P to T is the shortest distance from the line, this is the line, the shortest distance from the point to the line is always perpendicular to the line. shortest distance from a point to a line is perpendicular to the line. So this concept we have used here. Exercise 10.1, first question. How many tangents can be drawn? Can a circle have? See, this is a circle with center at O. Tangent is any line touching a circle at one point. So at this point we can draw a tangent, at this point can draw a tangent. At any point on the circle you can draw a tangent. And how many points are there on the circle? Infinite number of points are there. So there are infinite number of tangents to a circle. A circle can have infinite number of tangents. So answer you will write, a circle can have infinite number of tangents. Infinite number of tangents. At any point on the circle, a tangent can be drawn. At any point on the circle, a tangent can be drawn. Second question, you see, question number 2, solution. First one, a tangent to a circle intersects it at exactly one point. Exactly one point is like this, you see. This is the circle with center at O. If we draw a tangent, then it is intersecting circle at only one point. If it is intersecting, this is tangent. A line touching a circle at one point is tangent. And if you draw a line cutting a circle at 2 points, then it is called secant. Secant. That we will discuss again. So a tangent to a circle intersects it in exactly one point. A line intersecting a circle in 2 points is called secant. I have discussed here. If this is a circle, you draw a line touching a circle at 2 points, then it is a secant. And at 1 point, it is called tangent. A circle can have two parallel tangents. You see, third solution, question number 2, third one. Solution. A circle can have two parallel tangents. How, you see? This is a circle with center at O. At any point you draw a tangent, then exactly on the other side, on the other side, if through the diameter, if you take the other side, there is another tangent. So exactly two parallel tangents. A circle can have two parallel tangents at most. We cannot draw any more parallel tangent to the circle. Only if for any point diametrically opposite another. If you draw one tangent here, diametrically opposite another tangent. A circle can have two parallel tangents. The common point of a tangent to a circle is called point of contact. Point of contact. Like this point, this is the circle, center at O, this is the tangent. The point of intersection of circle and the tangent, this point is called point of contact. Then question number 3, exercise 10.1. Question number 3. Is like this. In a circle, say center at O, tangent, a tangent PQ, this is P, this point is Q, tangent PQ, radius 5 centimeter, this radius is 5 centimeter. A line through the point O meet at Q. From the point O to Q you draw a line, and that line distance is given 12 centimeter. Now what will be this PQ? You can just mark it X also. PQ is unknown X, and this is a right angle triangle. You can use Pythagoras theorem. Pythagoras theorem is hypotenuse square is equal to perpendicular square plus base square. So if you simplify, 144 equal to 25 plus x square. So 144 minus 25 is x square. 119 is x square, or x square is 119. Then x is equal to square root of 119 units. So the option is D. Question number 4. Draw a circle and two lines. Question number 4, solution. You are asked to draw a circle, center at O, and draw two lines parallel to a given line. So I can take a line, this is the given line, and parallel to this line you have to draw two lines. One is tangent. Tangent means touching circle at one point. So you can just draw like this at any position. Hey, I am drawing here, you can draw there, anywhere in this. So this is the given line, and a tangent parallel to the given line. Another is secant. Secant means touching the circle at 2 points, cutting the circle at 2 points. So this second line, it is secant, and this is the complete solution. Okay, touching the line at 1 point is tangent, cutting the circle at 2 points is secant, and if the line is passing through the center, then it is called diameter. And this is about and this is the solution, complete solution of exercise 10.1.